Performance monitoring. In this nugget, we're going to talk about monitoring the performance of various aspects of your system. The idea is that if we keep track of the way the system is performing, a load average of 3.2. It depends on, the processor, depends on the brand of processor, the speed of processor. All these things will affect what kinds of load average the particular processor can handle. Okay, so that being said, like I said, you just have to keep track of this, either look at it regularly, write a little script that pulls these numbers out and then writes them to a file and then averages them all up at the end of the day, and do that for a month or something, and then you'll see what a typical load average is on your system. Okay, so that's the uptime command. Now let's look at the top command. Well, we ran the top command back in the introductory videos. I just want to run it again right here real quick, just to refresh your memory as to what it was. Okay, top is this program that updates the screen sort of dynamically here based on the most current information about how much processes, how many resources processes on the system are consuming. Okay, so let's just look at the various columns in this chart. Okay, so the leftmost column here is the process identification number. The next column is the user or the owner of that particular process. If we jump out here, this is the percentage of CPU time that the processes are using, and this is the percentage of the memory, the RAM in our system that the processes are using. And then the command over here is the actual command that's being run by that process. Okay, so what we can learn from this is what processes on the system are consuming the most CPU time, the most memory, that sort of stuff. And if you can see here, if you watch this, here's this process by Annie. It's consuming 8.7% of the CPU, okay, and now it's jumped down to line 2 because some other process is consuming more. Now that process by Annie is consuming 8.9% of the CPU, and again, when it updates, it's down to 8.7. There's this process by Charles consuming 1.3% of the CPU, and now you can see it jumped up to 7.3. Okay, so it's this dynamic updating, right? And it's just like the most, like I said, the most current sort of snapshot of the system, right? Because inside the processor, these processes are, being exchanged in and out of the actual CPU hundreds of times a second, if not more. Okay, and so they're not getting large slices of the CPU at any one chunk, but this is just reflecting like the overall interval over the last 2 seconds, what percentage of the CPU time was used by that particular process. Okay, and if you want a more detailed discussion of the top command, go back to the introductory videos because we talked about all the various fields in here. We talked about all these numbers up here and what they mean. We talked about different options that you can use with the top command, or you can go through the info pages carefully and you can learn all that stuff there as well. Okay, so that's the top command. I'm just going to quit out of here with a Q, and then I'm going to show you another system monitoring tool that's like a graphical based system monitoring tool, and this is called the GNOME System Monitor. Okay, so here there's different tabs here. Process listing, you can see all the different processes, or you can get a graphical representation of how much CPU usage on the system, what's the memory usage, what's the swap space usage, that sort of thing. Okay, or you can go under process listing and then you can view different processes. So you can either view all the processes on the system, my processes, and since I open this window as root, they would be the processes owned by root, or I could go to active processes. I'm going to go there and see what's active on the system right now. And you can see kind of the same processes that were showing up at the top of the top screen. The processes by Annie and Charles. You can see the root process that's actually running the system monitor is consuming quite a bit of the CPU time. Okay, so this is telling us, again, a very quick sort of snapshot of the system, what's going on. Some people like, these graphs to give them an idea if these things are peaking up and down. It gives them a pictorial representation of what's going on the system. Okay, so this is just another tool that you can use to monitor activity on the system. Always be careful when you're monitoring activity on the system that you, by monitoring it, are not, putting it through and explain what some of this stuff is. Okay, so there's basically like 4 or 5 categories here: the processes, the memory, the swap, the I/O, the system, and the CPU. And now what I want to do is just explain what all these various subheadings are for each one of these. Okay, so the processes is the number of processes on the system that are waiting to run. That's what's under the R column. The B column is the number that are sleeping, and the W column is the number that are swapped out. Okay, under memory here are these four particular headings. Okay, SWPD is the number, or is the amount of virtual memory used on the system. Okay, free is the amount of free memory or idle memory, and buff and cache are basically memory that's being used for system processes. Buffers are like, the buffer memory is stuff that, you know, if you're writing to disk, well, you don't actually write to the disk, you write to this buffer, then the operating system writes the buffer out to disk. So that buffer memory is stuff that's being used by the system to accomplish those sorts of tasks. Okay, swap here is the amount that's been swapped in and swapped out, and you can see that's not being used because our system isn't really being loaded up. And I/O has to do with the number of blocks in and blocks out. So this is the number of blocks that have been sent to an I/O device, and this is the number of blocks that have been received from an I/O device. System here, IN stands for the number of interrupts per second, and CS is the number of context switches per second. So what's an interrupt? What's a context switch? Well, the short version is that an interrupt is generated by a program when it needs some resource in the system. Okay, so a program's running and it needs to write to disk. Well, it can't just control the disk and write to the disk. You know, everything would fall apart in your system, right? The operating system has to intervene here and actually take care of that write to the disk for the particular program, and the way that the program gets the operating system's attention is by causing an interrupt. Okay, so it's saying here there's 84 interrupts per second. The number of context switches per second is the number of times per second that the CPU sort of changes what program it's running. Okay, so it'll run a program for like a split second and then context switch, run some other program for a split second, that sort of thing. So a little while ago I was telling you that the CPU performance and active processes, we can keep track of those with the top command. The uptime command gave us those load averages for overall system performance. There was also the GNOME system monitor. I'll just abbreviate it like that. The way that you execute that is you type GNOME-system-monitor, and that was a graphical utility that let us see the active processes and the performance of the system. Memory usage, we could use the vmstat command. For disk usage and performance, we use the iostat command for performance of the disk subsystem. For disk usage, we would use commands like we learned back in the introductory Linux series. df and du were commands that would keep track of the disk usage of the system. CPU utilization, we did that with the MPStat, which stands for microprocessor statistics. For network usage, we would use the netstat command. Okay, and then don't forget about that suite of utilities that I mentioned at the end, which is systat. And anybody that's serious about keeping their system running at the highest performance possible and keeping track of how the system is running under various stresses and strains of day-to-day activities should be running systat and follow the advice in the manuals to run the cron jobs at the right times, and then you will have the ability to see the performance of your system in graphical output and have reports done on a daily basis. Well, I hope you found this nugget informative, and thanks for watching.